Assalamu alaikum guys, how are you? Welcome back to a new journey of fourth semester. We are starting our new subjects that is structure analysis, fluid mechanics, survey 2 and numerical analysis. So today lecture is about fluid mechanics. So first of all we have to talk about it why we studied fluid mechanics. What are the uses in engineering and specifically in civil engineering. So fluid mechanics is all about related to fluids that is liquid or air and mechanics is the study of motion. So it's mean that we are studying the fluids in motions. So in water resource engineering there must be a need of somewhat understanding or know-how of fluid mechanics that water delivered to consumer from tank, for example, that are used in irrigation in canal system, rivers and dams. Another is water power engineering. All the hydropower generating systems that must be in there must be need of some understanding of fluid mechanics. Other is fluid flood control and drainage system. There must be a need of fluid mechanics. And for structural engineering, like forces on the structure, either they are lateral forces, they may be due to earthquake or they may be due to wind load. And another is environmental engineering. So it's mean that in engineering there is also a need of understanding of fluid mechanics. So we are specifically now studied about it. What is mechanics? Mechanics is a study of motion and forces which causes or prevent the motion. So it's mean that mechanics is all related to the motion and the causes of motion, that which contents and which effects or which actions can produce this type of motion. Another is fluid mechanics, where we can study the fluids may be liquid or gas in their behavior at rest. So when the fluid is at rest we call it fluid statics. Are in motion, when the fluid is in motion we call it fluid dynamics. And the interaction of fluid with solid or other fluid. So when our fluid is interacted with solid body with their boundary, or when the fluid is connected to the other fluid, or when they are floating over the other fluid. So when we are finding the pressure over a fluid, so pressure become equal to force per unit area. And if this is a tank and this is the water surface, so the pressure will be same at the same elevation. So all over this water body, when you have go to the same elevation, there must be a same amount of pressure. So at the top surface there should also have a atmospheric pressure, so the pressure will be equal to atmospheric pressure. So if you recall the 9th 10th first year second year physics, you must have studied the pressure formula, that pressure become equal to rho gh. Rho is the density, g is the gravitational acceleration and h is the height. So if you have to calculate the pressure at a given point in fluid at rest, you must have to use this formula. Pressure become equal to rho gh. Now we can replace the rho g by a new constant, and that is specific weight, fluid specific weight. We call it gamma. So it's mean for rho gh we can replace it by a gamma. So pressure become equal to gamma h, and this gamma is fluid specific weight, and their unit is Newton per meter cube. So now this unit, how this unit come? So we are finding that for rho mean density, and density become equal to mass per unit volume. So the unit of mass is kg and the unit of volume is meter cube. Now if we have to study the gravitational acceleration, the unit of gravitational acceleration is equal to meter per second square. Now how this unit come? We are finding that. So this meter should be cut with this 1 meter, so there this become 2. So kg per meter square into second square. Now we can write it as kg per meter square into second square. Now I also write it as by multiplying meter in the denominator and upward. So it's mean that this should be meter should be applied in nominator and meter should be multiplied with denominator. So it will become kg meter divided by meter cube into second square. So we are studied that 1 Newton should be equal to ma. M is the kg and acceleration is the meter per second square. So the unit of Newton is kg meter per second square. And here we are saying that this is kg meter per second square. So we can replace this by Newton. So when we replace this by Newton, so it will become Newton, and this is in divide in meter cube. So these units come, and we can replace these two units by this one, and that is Newton per meter cube. Now 1 pound per square feet should be equal to 47.88 Newton per meter square. You must be remember that. Now we are moving towards the different units and how to convert these units among each others. Because if you recall the first year and second year physics, you must have known and you must have studied about that how to convert one units into another units because if you have to solve the problem, you must have to keep this assumption that all the units should be consistent. If your unit does not consistent, there should be gives us a wrong answer. So that's why we are keep some standards, or we are keep eye on that units that this much should have to be consistent. The force unit in the British, they should have 1 pound. In the SI unit, the force unit is 1 Newton. So 1 pound become equal to 1 slug into 1 feet per second square, 1 foot per second square. So 1 pound can be replaced in SI by 1 Newton. 1 Newton become equal to 1 kg into 1 meter per second square. Now 1 slug is also the unit of mass, and 1 kg is also the unit of mass. 1 foot per second square is also the unit of acceleration, and 1 meter per second square is also the unit of acceleration. So now one slug, how slug can be derived? What is slug? So slug is equal to 0.453592 kg. Now this is the mass of a platinum standards. We can take a platinum standard, and the mass of 0.45 platinum should be equal to 1 slug. Mass of 0.453592 platinum should be equal to 1 slug. Now the value of G, if you have to use the value of G, and if you have to get the answer in meter per second square, you must have to use the value of G in meter per second square, and that should be 9.81 meter per second square. If you have to need, if you have to need answer in feet per second square, you must have to use the value of G in foot per second square, that is 32.2 foot per second square. Now weight is equal to mg. Weight is equal to mg. Now m is mass and g is gravitational acceleration. So for mass we can put 1 slug, and for g we can put 32.2 foot per second square. So they should be equal to 32.2 pound. Pound is the unit of force in British, while weight should also be equal to 1 kg, that is the unit of mass, and 9.81 meter per second square. So this should be equal to 9.81 Newton. So if you have to find the weight in pound, they must have to be equal to 32.2. If you have to find the weight in Newton, they should be equal to 9.81 Newton. Now 1 dyne should be equal to 10 raised to the power minus 5 Newton. 1 foot should be equal to 0.3048 meter. Now as you know that 1 meter should be equal to 3.28 feet. So if you have to convert it, 1 feet will be equal to 0.3048 meter, and 1 inch should be equal to 25.4 mm, 25.4 millimeter. Now 1 slug, it is the unit of mass. So 1 slug should be equal to 1 pound into divided by 1 foot per second square. This is this formula. If you keep this 1 slug in their place, and if you, this is in multiplication, if you can place it over the equality, they will become divided by 1 pound. So it will become 1 pound divided by 1 foot per second square, and they should be equal to 1 slug. So we are right, it is 1 slug is equal to 1 pound divided by 1 foot per second square. So 1 pound become equal to 4.448 Newton. 1 feet per second square, 1 foot become equal to 0.3048 meter. If you have to find the answer in meter per second square, so it will become that 1 slug should be equal to 14.59 kg. This is universal. As you know that pound in Newton, this is the alternative units. In other hand, the slug in kg is in the alternative units. So 1 slug should be equal to 14.59 kg. 1 slug should be equal to 14.59 kg. So now 1 pound should be equal to 0.453592 multiplied by 9.81. So the pound value will be 4.48 Newton. We can replace this pound by 4.48 Newton. So as we already said that Newton and pounds are alternative units. 1 Newton should be equal to 0.225 pound, and 1 pound should be equal to 4.48 Newton. So these are alternative. You can convert one from other and other from Newton or this one. 1 meter should be equal to 39 inches or 3.28 feet, and 1 kilometer should be equal to 5/8 miles. So in other hand, 1 mile should be equal to 4,000 meter, and 1 hectare should be equal to 2.5 acres. So in today's lectures, we are studying the basics, that why we studied fluid mechanics and how to convert different units. In next lectures, we are starting from our first lecture, that is all about fluid mechanics, their properties, then specific volume, specific gravity, then viscosity. So in the next lectures, we are moving towards that. Thank you. Allah Hafiz.